Hello students, welcome back to the channel Physiology Redefined. Today I will talk about the graded potential. In the last video I discussed the membrane potential during resting condition. That means once the cell membrane is not stimulated, then what type of potential difference exists across the cell membrane, which is known as the resting membrane potential. Now is about if the cell is stimulated, cell membrane is stimulated, any stimulus is applied to the cell membrane, then the potential difference across the membrane gets changed. Whatever potential difference was there during resting condition, that doesn't remain same, it gets changed. Now, what type of change takes place in response to the stimulation of the cell membrane? That I will discuss in this video. So please see the video till the end, and if you like it, share this video, press the like button and subscribe this channel. Now regarding the, as I told, if the stimulus is given, then membrane potential gets changed. That means membrane potential in response to the stimulation. Now potential difference across the membrane gets changed in response to the different type of stimulus. It depends on the subthreshold stimulus or the threshold stimulus. Subthreshold stimulus means the intensity of the stimulus is low, which doesn't evoke the response, which doesn't generate the response. Whereas the threshold stimulus is that type of intensity of the stimulus which can generate the response. So first we'll talk about if we apply the subthreshold stimulus on the cell membrane, then what type of membrane potential is developed, and that membrane potential which is created across the cell membrane in response to subthreshold stimulus is known as the graded potential. Graded potential. So let us see now first what is graded potential. So suppose this is again the cell membrane. This is the cell membrane. Now this is the outside of the membrane and this is the inside of the membrane. Now as I told that a electrode is placed in the outside of the membrane and another electrode is placed at the inside of the membrane, which is connected to the galvanometer. But here we have to record the membrane potential. So in this case we'll connect these two electrodes at the special type of instrument that is known as the CRO, cathode ray oscilloscope. So two electrodes are connected with the cathode ray oscilloscope. And now this cell membrane, this is the recording electrodes. These two are the recording electrode. Now as I told, in this case cell membrane has to be stimulated by the electrical stimulus. Electrical current has to be applied through a stimulator, and that stimulator, suppose this is one stimulator, this is one stimulator and another stimulator. By the help of these two stimulators, it is connected with the electrical current. The source of electrical current, from the source of electrical current, two electrodes are applied on the cell membrane. One is known as the cathode. So this is suppose cathode, and this electrode is known as suppose anode. So this is the anode. So to stimulating, by the help of two stimulating electrode, we can apply the electrical current on the cell membrane to excite the cell, membrane, and whatever membrane potential gets changed, that can be recorded via the recording electrode through the cathode ray oscilloscope instrument. Now what's happened? Suppose we are applying, this is the minus 90 millivolt. This is the minus 90 millivolt. That is the resting membrane potential. Now a stimulus, strength of which is 1 millivolt, is applied on the cell membrane. 1 millivolt electrical strength stimulus is applied on the membrane. In such a case, this potential will not remain minus 90. Potential will get changed. For example, this is changed to minus 80 millivolt. This is changed to minus 80 millivolt. Now suppose strength is a little bit increased, that is 2 millivolt. 2 millivolt electrical current is applied on the cell membrane, and obviously this is suppose minus 75 millivolt. So potential difference will be a little bit reduced. So it will be suppose minus 75 millivolt. In response to 2 millivolt, the magnitude of the potential difference increases much, that is suppose minus 75 millivolt. Now we have increased the strength of the stimulus to 4 millivolt. In such a case, what's happened? Suppose this is the minus 70 millivolt. This will be minus 70 millivolt. This will reaches up to minus 70 millivolt. That is known as the firing level. And if it reaches at the firing level, the very spike potential difference will develop, and that is known as the action potential or AP. But in this case, here you see in this case, so in this case what's happened? In response to 1 millivolt and the 2 millivolt intensity of the stimulus, once applied, the potential, there is a small change of the potential difference. This small change of the potential difference in response to application of the subthreshold stimulus, these are the subthreshold stimulus. So in response to application of the subthreshold stimulus, there is a slight changes of the membrane potential. And this slight changes of the membrane potential is known as graded potential. This is known as graded potential. So what is graded potential? What is graded potential? Number one, it is the local changes of the potential, local changes of small magnitude. Small magnitude. Change of the membrane potential is local and with small magnitude, and this is originated in response to subthreshold stimulus. So this is in response to subthreshold stimulus. Moreover, this type of response, this type of change of potential of small magnitude, local one, that will die out within 2 to 3 millimeter of the site of application of the stimulus. It will not propagate from one part to another part. That means if a stimulus is applied here, this will not propagate from one part to another part. This will be die out within this zone. This will die out within this zone. This will die out within this zone. This will fade out within this zone. This will not propagate. This will not propagate from the site of stimulus beyond the site of stimulus. So this is the non-propagatory. So this is non-propagatory. So what is graded potential? Graded potential is the local changes of the membrane potential. Local changes of membrane potential of small magnitude which is originated in response to subthreshold stimulus, and that is non-propagatory, that dies out within 1 to 3 millimeter of the site of application of the stimulus. So this is the graded potential. Now this graded potential, what are the causes of the graded potential? What are the reason of this change of this graded potential? Let us see now what are the causes of change of this membrane potential. So causes or reason of causes of graded potential. The reason of the graded potential is the either entry of the sodium ion from outside to inside. So suppose this is the cell membrane, as I told, a electrode with the current source, electrical current source is connected and stimulus is applied. Now at that particular part, at this particular part where the stimulus is applied, at this particular part where the stimulus is applied, there is a diffusion of the sodium ion from outside to inside. Diffusion of the sodium ion from the outside to inside at the cathode end, and at the anode end, this is the anode. At the anode end, what's happened? There is a diffusion of the potassium ion from inside to outside. So that means at the site of the stimulation, either there is a diffusion of the sodium from outside to inside and thereby change of the potential difference across the membrane, or there is a exit of potassium ion from inside to outside, exit of positive ion from inside to outside, and thereby there is a change of the membrane potential, local change of the membrane potential. So the causes of the graded potential, this is due to either entry of small magnitude of the sodium ion, small magnitude of sodium ion inside, or exit of small magnitude of potassium ion from outside. So this is the reason or cause of the changes of the membrane potential in response to application of the subthreshold stimulus. Now regarding the properties of the graded potential. Properties of graded potential. So what are the properties of the graded potential? So this is the causes of graded potential. Next is the properties of the graded potential. So first property of the graded potential is the decremental in nature. This is decremental in nature. That means it dies out or fades with time and with distance. This dies out, this fades out with time and distance, and thereby that property is known as the decremental in nature. That means at this particular part, suppose at this particular part, whatever magnitude was there, in this part this magnitude will be decreased, in this part magnitude will be further decreased, in this part magnitude will be very less, and thereby it will die out. So with the passage of time or passage of distance, the magnitude of the membrane potential in response to change, in response to application of the substitution stimulus or graded potential will die out, will be faded. It will not propagate from one part of the membrane to other part of the membrane. So as it is decremental in nature, so second one is it is non-propagatory in nature. It will not propagate, non-propagatory in nature. That means this whatever changes will take place. Suppose because of the sodium entry, this will become plus, inside will be electropositive, but this electropositivity will not go beyond the site of origin. So it will not propagate from the site of origin, and this is why this property is known as the non-propagatory in nature. Third one, it is depolarizing and hyperpolarizing in nature. Depolarizing and hyperpolarizing in nature. That means suppose here you see this is the minus 90 millivolt. A stimulus is applied, for example 1 millivolt. This is minus 85, minus 80, minus 75, minus 70. So suppose 1 millivolt is strength is applied, from minus 90 it will be decreased to minus 85 millivolt. This will be minus 85 millivolt. If the strength of the stimulus is increased, then it will be, magnitude will be further increased, that is minus 90 suppose. If the magnitude is further increased, magnitude of the strength of the stimulus is further increased, then magnitude of the membrane potential will be further increased to suppose minus 75 millivolt, and if the stimulus intensity is far increased, then for example the membrane potential will be increased to minus 70 millivolt, and once it will increase to minus 70 millivolt, that will result the action potential or peak, very sharp fall of the minus electronegativity, overshoots minus, and ultimately a sharp peak will be there, that is known as the action potential. Whereas all these potential changes in response to subthreshold stimulus, these are all the subthreshold stimulus. In response to subthreshold stimulus, whatever potential differences are getting changed, these are known as the depolarizing graded potential, because these are in the positive side, that means electronegativity is getting decreased. Similar, this will take place in the cathodal part. At the cathodal part. At this part, because of the sodium entry, these changes will take place. On the other hand, in the anodal part, as the potassium ions are going out, positive ions are going out, electronegativity will be further decreased. For examples, with the same stimulus strength, it will be towards the minus directions. If the intensity is further increased, this will be further, electronegativity will be further decreased. And if the strength is further increased, then at the anodal end, this potential difference, electronegativity will be further decreased. So this at the negative side, once the electronegativity is further reduced at the anodal end, then that type of potential changes of the gradient potential is known as the hyperpolarizing graded potential. So graded potential can occur in two directions, positive directions and negative directions. Positive directions, if it goes, it is known as the depolarizing graded potential, and that happens in case of cathodal end. Whereas if it is in the negative direction, that is known as hyperpolarizing graded potential, which takes place in the anodal end. So this is how the graded potential has got depolarizing and the hyperpolarizing in nature. And lastly, the graded potential can be summated. This can be summated. That means if the stimulus is applied more, strength of the stimulus is more. Here you see strength of the stimulus is from 1 millivolt. It is like this. It is like height of like this. If it is 2 millivolt, height is getting increased. And if it is 3 millivolt, height is getting further increased. So in this case, the response are getting added. So these response are getting added. So as the response are getting added, response are summated. This type of response or this type of potential difference is known as has got the summated actions, or it can be summated, it can be added. So these are the properties of the graded potential. And finally, the different forms of the graded potential. Forms of graded potential. What are the different forms of graded potential? In case of receptors, the graded potential is known as the receptor potential or generator potential. This is number one. In case of neuromuscular junction, this graded potential is known as the end plate potential, EPP, end plate potential or EPP. Similarly, in case of synaptic connections between the nerves, neurons, the graded potential is known as the excitatory postsynaptic potential or inhibitory postsynaptic potential, IPSP, EPSP or IPSP. And in case of suppose SA node of the heart, this graded potential is known as the pacemaker potential. That means all these are the forms of graded potential. receptor potential or generator potential, end plate potential, EPSP or IPSP, and even pacemaker potential present in case of SA node of the heart are all the examples of the graded potentials, in which are the changes of the potential difference across the membrane, very small changes, localized changes. It is not propagatory, and it can be added, it can be summated. So this is all about the graded potential. I hope you will like this video, and again, if you feel it is helpful to you, don't forget to subscribe this channel. Thank you.